Welcome back to my channel. In this video, I'll talk about exponents, and some people call them indices. Some others call them powers. Simple example for exponents: 5 to the power 2, or 5 squared. We call the 5 base, and we call 2 the exponent. Simply, exponents are math operations. They are exactly as the addition, multiplication, subtraction, or division. Let me start by some examples. 5 squared, or 5 to the power 2. Exponents are repeated multiplication. If you remember the multiplication 5 times 2, it means that we are adding the 5 to itself 2 times, and the answer is 10. So the multiplication is repeated addition. But for the exponents, they are repeated multiplications. So 5 to the power 2 is not as usual, as many students do, it's 10. The answer is not 10. 5 to the power 2, it means 5 multiplied by itself 2 times, and the answer is 25. What about 2 to the power 5? It means we are multiplying 2 by itself 5 times. So it's 2 times 2 times 2 times 2 times 2, 5 times. And the answer is 32. Did you notice anything? I did. 5 to the power 2 is not as 2 to the power 5. So the exponents do not have the commutative property. It's not like the multiplication. If we did 2 times 5, it means add 2 to itself 5 times, and the answer is going to be 10, exactly as this. In case of 5 to the power 2, we got 25, but in case 2 to the power 5, we got 32. So the exponent do not have the commutative property. What about 2 to the power 3? It means we multiply 2 by itself 3 times, and the answer is not 6. It's not 2 times 3, it's 2 by itself 3 times, and the answer is 8. Again, 3 to the power 2, it's 3 times itself 2 times, and the answer is 9. What about 3 to the power 4? It means we multiply 3 by itself 4 times, and the answer is 81. Now I'll mention some rules that will help in simplifying exponents. Any positive number raised to an even power or even exponent will give us positive. And if the positive raised to an odd number, the answer is going to be positive as well. In case of having negative and the exponent is even, so the answer should be positive. But the even should cover the whole number along with its sign. So if we have like minus and then the number raised to an even number, the answer should be negative. I'll give some examples. For this, if we will see later, if we have like negative 2 to the power 3, Now, in case of having negative value raised to an odd number, the answer should be negative. What if we have like a, any number, raised to a negative power? Negative power means you flip the number. You have to take the reciprocal of the number. So it's like taking the whole thing, the whole quantity here, and put it as 1 over a to the power b. As if you are flipping, but then you have to change the sign of the exponent or the power or the index to be positive instead of being negative. This property is the property for power to raised to another power. So a raised to b, and then the whole quantity raised to c. If we have power raised to another power, then we have to multiply the powers. So it's going to be the same base, which is a, and then multiply b and c. We will see some examples. What if we want to have the value or evaluate 5 to the power 2? 5 is a positive number and raised to an even number. So the answer should be 25 because it's 5 times 5 and the answer is 25. Now 5 to the power 2 again, but 5 within 2 brackets. Again, the answer should be the same because we have an even number and positive number here. So the answer should be positive. No need to write the positive sign. The answer is 25. Again, why? Because it's 5 times 5 and the answer is 25. 2 to the power 3. 3 is odd. But 2, which is the base, it's positive. So the answer is going to be 8. Why 8? Because it's 2 times 2 times 2, and the answer is 8. And finally, still, we have 2, but between 2 brackets. 2 is positive. We don't care about the exponent. If it is even, the answer should be positive. If it is odd, the answer again should be positive. So this one is going to be 8. Why? It's again because 2 times 2 times 2, which is equal to be 8. Now, what if we have a negative base? Remember what I mentioned about the negative base. If the base is negative and the exponent is even, then the answer should be positive. Now forget the negative, forget this. 5 to the power 2 is 25. If we want to check, we know that negative, what do we mean by negative 5 to the power 2? It's negative 5 times negative 5. Remember, negative times negative is positive, and 5 times 5 is 25. Now be careful with this. Whenever you have like this number, it means the minus is outside the exponent. So it is like minus and then 5 raised to the power 2. So we have to evaluate this quantity and forget the minus or the negative. See the difference between this and this? Here 2 is covering the whole quantity, which is negative 5. But here 2 is covering only the 5. So minus is outside, leave it minus. Now evaluate 5 to the power 2. We know that 5 to the power 2 is 25. Now, if we want to give more details for this, it's like minus is outside, and then we are multiplying 5, because 5 to the power 2, it means 5 by itself twice, or 2 times. 5 times 5. So 5 times 5 is 25, and we have a minus or negative outside, so it's minus 25 or negative 25. Third example, minus 2 to the power 3. Now be careful. We have a bracket, a negative value, but the exponent is odd. So we are expecting, according to the rules that we just covered, to have a negative answer. Now we put the negative. Forget the negative. 2 to the power 3, we know that it is equal, it's 8. If we want to give the details, okay, minus 2 to the power 3. This means what? Minus 2 times minus 2 times minus 2. We know that minus 2 times minus 2, minus times minus, or negative times negative is positive, so it's positive 4. Then times this quantity, which is negative 2. Positive times negative will give us negative. 4 times 2 is 8, so the answer is negative 8. Now, negative 2 to the power 3. The negative is outside. 2 only is raised to the power 3. So leave the negative. We know that 2 to the power 3 is what? Is 8. So the answer is negative 8. If we want to give the details, this means negative, and then put the bracket. 2 times itself 3 times 2 times 2 times 2, and the answer is negative. 2 times 2 times 2 is known to be 8. The multiplication rule. If we have two numbers raised to exponents and we want to multiply them, the most important thing in case of the multiplication of exponents to have similar bases. If we have the similar bases, then we just add the exponents, a plus b. Example, 2 to the power 3 times 2 to the power 4. Now what I want you to notice here, 2 the first base and 2 in the second base. So the bases are the same, so the answer is 2 to the power 3 plus 4, and the answer is 2 to the power 7. By the way, the question here is asking to simplify, not to evaluate. Then if you want to continue, you can say 2 times itself 7 times. What about 3 to the power 5 times 3 to the power negative 2? The answer again, the bases are the same, 3, and then you have to add the powers and say 5 plus negative 2, which is 3. 5 plus negative 2 is equal 3. So the answer is 3 to the power 3. If you want to continue, you can say that's 3 times itself 3 times. Negative 5 to the power 2 times 5 to the power 6. Remember, the exponent is not covering the negative value, so I'll leave the negative outside. And then we can do like this. 5 to the power 2 times 5 to the power 6. So the negative outside. 5 to the power 2 times 5 to the power 6, you need to add the powers because the bases are the same. So 5 to the power 2 plus 6, which is 5 to the negative 5 to the power 5 to the power 8. No need to have the bracket now. What about minus 5 between two brackets to the raised to the power 2 times 5 to the power 6? Again, we need only to simplify. Remember, 2 is what? Is an even number. And negative 5 to the power 2 will give us a positive value. So as if we are canceling this, as if the negative value is not here. So as if we are multiplying 5 to the power 2 times 5 to the power 6. And the answer is going to be 5 to the power 2 plus 6, which is 5 to the power 8. Another example. Negative 5 to the power 3 between two brackets times negative 5 to the power 4 between two brackets. Actually, I can give you two methods to solve this. the first one, which is what we know. Now, since the bases are the same, negative 5 and negative 5, we can say that's negative 5 to the power 3 plus 4, which is negative 5 to the power 7. Or, it's known that since 3 is odd, we can get the negative value outside, which is minus, and then I can say I have like 5 to the power 3 times. Since 4 is odd, as we did here, 4 is even, as we did here, no need for the negative sign. So as if we are multiplying by 5 to the power 4. Now keep the minus outside, bring it here, it's minus. And then the bases are the same, 5 to the power 3 plus 4, which is minus, and then 5 to the power 7. Now, since 7 is odd, this should be negative, so we can't get the negative outside. So this, if we want to continue, it's minus and then 5 to the power 7. Negative 5 to the power 2 and negative 5 to the power 4. And the negative and the both bases are between two brackets. Remember, 2 is even and 4 is even as well. So cancel this and cancel this. So as if we have 5 to the power 2 times 5 to the power 4. The answer here is 5 to the power 2 plus 4, which is 5 to the power 6. Another way to solve this. What if we didn't notice that the exponents are even? So we can say that minus 5 to the power 2 plus 4, which is minus 5 to the power 6. Now, 6 is even, so we can cancel the negative value. So the answer can be as 5 to the power 6. No need for this negative value. Continuing with the examples. Negative 5 between brackets to the power 3 times negative 5 raised to the power negative 4. Now, 3 is odd. We don't care about the sign of the exponent. We care if it is even or odd. So I'll not consider the negative, but I'll consider 4, and 4 is even. Now, we know that in case of odd, we can get the negative outside, and in case of even, we can cancel the negative sign. So negative and then 5 to the power 3 times 5 to the power negative 4. So it's negative again. This negative will come here. The bases are the same, 5 and 5. And then add the powers, 3 plus negative 4. So it's minus, and then 5. 3 plus negative 4 is known to be negative 1. Do you remember one of the rules? So leave the minus, and then we need to flip this. So it's 1 over 5 to the power 1. The only power that we don't write is power of 1, or exponent 1, or index 1. So no need to write this exponent. So this as it can be written as 1 over 5, negative 1 over 5. Okay, negative 5 to the power 2 and negative 5 to the power negative 4. This is even, and this is even again. So cancel this and cancel this, as if we are multiplying 5 to the power 2 times 5 to the power negative 4. So it's 5 to the power 2 plus negative 4. So it's 5 to the power 2 plus negative 4 is negative 2. Negative exponent, we can put it in the denominator. So it is 1 over 5 to the power 2. The only thing, as we did here, we have to change the sign. And here we have to change the sign. Just flip it and change the sign. Negative 5 to the power negative 2 and negative 5 to the power negative 4. We don't care about the signs of the exponents. We have 2 and we have 4, and both of them are even. So it's 5 to the power negative 2 times 5 to the power negative 4. And it is 5 to the power negative 2 plus negative 4, which is 5 to the power negative 6. Again, use this trick here. It is 1 over 5 to the power. Instead of negative 6, it will become a 6. 2 to the power 3 times 4 to the power 5. Now, stop here. What I want you to notice here is the bases 2 and 4. They are not the same. Be careful. They are not the same. What we should do, we try to unify them. We know that 4 is what? 2 times 2. Start with the large number, which is 4. If you can write it as a multiplication of the smallest number by itself. So it's 2 by 2, which is 2 to the power 2. So 2 to the power 3 times, and instead of 4, I'll write what? 2 to the power 2, and then I'll write the other power, which is 5. Do you remember the rules for the power to the power? What we should do, if we have power raised to another power, we have to multiply the powers. So it's 2 to the power 3 times 2 to the power 2 times 5, which is 2 to the power 3 times 2 to the power 10. Again, which is 2 to the power. Now the bases are the same, so we can add 3 plus 10, which is 2 to the power 13. Another example. 27 times 3 to the power 5. First of all, if a number written without any power, it means the power again is equal 1. So this one, as if we have 27 to the power 1 times 3 to the power 5. Can we write 27 in terms of 3? Let's try. 27 actually is 3 times 3 times 3, which is 3 to the power 3. So we can replace 27 by 3 to the power 3 and then raise it to the power 1 times 3 to the power 5. But 3 to the power 3, 3 times 1, which is 3, is going to be 3 to the power 3 times 3 to the power 5. The bases are the same. Add the exponents. 3 to the power 3 plus 5, which is 3 to the power 8. 16 to the power 3 times negative 4 to the power 5. First of all, can we write 16 in terms of 4? Forget the negative of 4. The other number is 4. Yes, we know that 16 equal 4 times 4, which is 4 times 4, which is 4 to the power 2. So instead of writing 16, I'll write 4 to the power 2 raised to the power 3 times. Now 5 is odd, so we need to get the negative outside. Times negative, this is times, and negative, and 4 to the power 5. Now what you should do, you should bring the negative at the beginning, negative. 4 to the power 3, 2 to the power 3 is known to be 4 to the power 2 times 3, which is 6, times 4 to the power 5, which is, again, bring the negative at the beginning, and it is 4 to the power 6 plus 5, which is negative, and 4 to the power 11. Minus 27 times 3 to the power 2. We know that negative 27 or 27 only is equal 3 to the power 3. So it's minus or negative 3 to the power 3. So 3 to the power 3 is replacing the 27 times 3 to the power 2. Bring the minus at the beginning, it will become negative here. And this is 3 plus 2 because of the multiplication. The bases are the same. So it's negative and 3 to the power 5. Negative 5 to the power 2 and times negative 125 to the power negative 6. Again, 2 is even and 6 also is even, 6 only. But the bases are not the same. We have negative 5 and negative 125. But let's get rid of the negative sign because both of the exponents are even. So it's 5 to the power 2 times 125 to the power negative 6. Okay, now 125 is known to be 5 times 5 times 5, which is 5 to the power 3. So instead of writing 125, I replace it with 5 to the power 3. So it's 5 to the power 2 times 5 to the power 3 to the negative 6. I'll continue here. 5 to the power 2 times. What we should do, power raised to another power, we should multiply the powers. 3 times negative 6, so it's 5 to the power 3 times negative 6, which is 5 to the power 2 times 5 to the power minus 18. The bases are the same. What we should do, we should add the powers or the exponents. 5 to the power 2 plus negative 18, which is 5 to the power 2 plus negative 18 is negative 16. Since the power here, or the exponent is negative, so we have to flip it 1 over 5 to the power 16. Now we will move to the division. Remember, in case of the multiplication, we ask to have similar bases and then add the exponents. In case of the division, we need to have similar bases and then subtract what we have in the numerator minus what we have, the exponent, what we have in the denominator, a minus b. I'll repeat the same examples that I just covered for the multiplication, but instead of having multiplication, we will have division. Similar bases, 2 to the power 3 over 2 to the power 4. The answer is going to be 2 to the power 3 minus 4. Why? Because 3 in the numerator and 4 in the denominator, and we have the similar bases. So it's 2 to the power negative 1. We know that 2 to the power 4, negative 1 is 1 over 2 to the power 1, which is the same as 1 over 2. 3 to the power 5 divided by 3 to the power negative 2. The same, we have similar bases, 3, 5 minus negative 2, which is 3 to the power. Now in case of negative and negative, negative with negative, we have to multiply them and they will become as positive. So it's 5 plus 2, which is 3 to the power 7. Negative 5 over to the power 2 over 5 to the power 6. Remember, this is true that's even, but it's not covering the negative value. It's not between brackets. So leave the negative and then say 5. Okay, so negative over positive will become as negative. And then 5, 2 minus 6, because this is 2 and this is 6. So as if I cut this into two problems. The negative came here, and then another question, 5 to the power 2 divided by 5 to the power 6. So it's 2 minus 6, which is negative 2. 2 minus 6 is negative 4. But we know how to deal with this. It's minus 1 over 2 to the power 4. By the way, if you write it this way, it's the same. 2 to the power 4. Negative 5 to the power 2 divided by or over 5 to the power 6. But this is even. In case of having even and the sign between two brackets covered by this even exponent as if it is not here. So cancel it. So as if we have 5 to the power 2 over 5 to the power 6, which is 5 to the power, subtract the exponents, 2 minus 6, and 5 to the power negative 4. So it's 1 over 5 to the power 4. What about this question? The negative here, negative, and then 5 to the power 3. Why? Because 3 is odd, so get this outside. But this is even over 5 to the power 4. We can write it between two brackets. Now the negative will come, negative. Now 5 to the power 3 and 5 to the power 4, so it's 5 to the power 3 minus 4, which is minus 5 to the power negative 1, which is negative or minus. We know how to deal with this, 1 over 5 to the power 1, which is the same as minus 1 over 5. Negative 5 to the power 2 divided by negative 5 to the power 4. This is even and this is even. Both of them are even, so no need to deal with the negative because they are covered by the exponent. So it's 5 to the power 2 divided by 5 to the power 4, which is 5 to the power 2 minus 4, which is 5 to the power negative 2, which is 1 over 5 to the power 2. Negative 5 to the power 3 divided by negative 5 to the power negative 4. This is odd and this is even, which is minus, and then you can write it as 5 to the power 3 over, cancel this because this is even, 5 to the power negative 4. So what will be the answer? Bring this one here, 5 to the power 3 minus negative 4, which is minus 5 to the power, negative with negative will become as positive, so it's 3 plus 4, which is negative 5 to the power 7. Negative 5 to the power 2 and negative 5 to the power negative 4, both of them are even. So it's minus, sorry, it's cancel this with this, as if we have 5 to the power 2 over 5 to the power minus 4, which is 5 to the power 2 minus negative 4, which is 5 to the power 2 plus 4, which is 5 to the power 6. Negative 5 to the power negative 2 and negative 5 to the power negative 4. Negative 2 and negative 4 are even. So cancel this, 5 to the power negative 2 and 5 to the power negative 4, which is 5 to the power negative 2 minus negative 4, which is 5 minus 2. Minus with minus, consecutive two negative values will become positive 4, which is 5 to the power negative 2 and plus 4 is equal to 2. 2 to the power 3 and 4 to the power 5 to the power 5. Be careful with this example. Now what we have to do, remember, we need similar bases. but this is 2 and this is 4. The same trick that I used before, 2 to the power 3 it will remain, but we know that 4 can be written as 2 to the power 2. So it's 2 to the power 2 and then to the power 5. So it's 2 to the power 3 over 2 to the power 10. What we should do, we should subtract 2 to the power 3 minus 10, which is 2 to the power negative 7. In case of having negative exponent, 1 over 2 to the power 7. 27 divided by 3 to the power 5. Be careful with this example. 27 can be written as 3 to the power 3 over 3 to the power 5, which is 3 to the power, similar bases, 3 minus 5, which is 3 to the power negative 2, which is 1 over 3 to the power 2. 16 to the power 3 divided by negative 4 to the power 5. 5, first of all, is odd. We need to get this outside, and then the 16 can be written as 4 to the power 2. Again, we need to unify the bases. So it's 2 to the power 2, it's 4 to the power 2 to the power 3. So this 4 to the power 2 is representing the 16 divided by negative 4 to the power 5, which is 4 to the power, when we have 2 times 3, the answer is 6 over negative, and this is 4 to the power 5. The negative, whether it is in the denominator or numerator, you can write it here or in the numerator. And then do the 4, 6 minus 5, which is negative 4 times 6 minus 5 is 1, which is negative 4. Minus 27 or negative 27 divided by 3 to the power 2. Negative, leave it as negative, and then 27 over 3 to the power 2. We know that 27 is 3 to the power 3. So it's negative, and then 3 to the power 3 divided by 3 to the power 2, which is negative. 3 to the power 3 divided by 3 to the power 2 is 3 to the power 3 minus 2, which is negative 3 to the power 1, which is negative 3. Minus 5 or negative 5 raised to the power 2 and negative 125 raised to the power negative 6. This is even and this is even. So get rid of this. 5 to the power 2 divided by 125 to the power 6. We know from the previous examples that 125 is 5 to the power 3. So it's 5 to the power 2 divided by 5 to the power 3. All of this raised to the power 6. So it's 5 to the power 2 divided by, when we have two powers raised, power raised to another power, we should multiply the powers. So it's 5 to the power 18. 5 to the power 2 over 5 to the power 18 is 5 to the power 2 minus 18, which is 5 to the power negative 16, which is 1 over 5 to the power 16. Remember the previous rule that we multiply two numbers with the same bases, but the difference in having whether we have similar exponents or different exponents. Now, what if we have two numbers, they are multiplied by each other and then they are raised to the same power? In case of having x times y to the power a, remember the previous rule, we have x to the power a times x to the power b. So the first number is the same, the first base is the same as the second base, okay? But the first one is raised to a power and the second one is raised to another power. Possible to have the similar powers. But here, no, it's x times y, two different numbers, possible to be the same. They are raised, by the way, this is not equal. They are raised to another exponent, which is a. What we should do, we can distribute the exponent. So the first one will take the exponent and the second one will take the same exponent, x to the power a and y to the power a. And the same thing in case of the division. X over y raised to an exponent a, x will take the a and y will take the a as well. X to the power a and y to the power a. Let me give you some examples. Again, here we are asking not to evaluate, only to simplify. 2 times 4 to the power 2. We can say this, according to the rule of the multiplication, 2 will take the 2 times 4 to the power 2. If we want to continue, 2 to the power 2, we know that 4 can be written as 2 to the power 2 again. 2 to the power 2 again raised to the another power, which is 2, which is 2 to the power 2 times 2 to the power this times 2, this times this, which is 4. So the answer is going to be 2 to the power 2 plus 6, which is 2 to the power 8. What about minus 15 over 7 raised to the power negative 3? Now, 15 can take the negative 3 and 7 can take the negative 3. Nothing in common between the 15 and the 7. By the way, so we can't continue. Stop here. By the way, this one is exactly, so this quantity is exactly as 7 over 15 to the power 3. So we can flip. The denominator will become as a denominator, and the numerator will become as the denominator. Denominator will come as numerator, and then change the sign of the exponent. So these two quantities are the same. Why? I can prove this. Like 15 to the power minus 3 or negative 3 and 7 to the power negative 3. First of all, we know that this can be written as what? 1 over 15 to the power 3. And this, if we flip it, it will become as 7 to the power 3 over 1. So this times this will give us 7 over 3, and this 15 to the power 3. See, they are the same, because at the end we can write this as 7 over 15 to the power 3. 8 times 5 to the power 2 times 5 to the power 3. Remember that we should distribute. We can't say anything because the base here is different than here. So this is 8 to the power 2 times 5 to the power 2. This is for the first quantity. Times 5 to the power 3. Can we do this or not? Yes, we can. So it's 8 to the power 2 times, this will become as 5 to the power 2 plus 3, which is 8 to the power 2 times 5 to the power 5. And we can't do anything because nothing in common between the 8 and the 5. 6 to the power 4 times 2 to the power 5. The bases are not the same. But can we write 6 in terms of 2? Yes. 6 can be written as 2 times 3 to the power 4. So I replace 6 with 2 times 4, 2 times 3, times 2 to the power 5. So this will become as 2 to the power 4, and then 3, we can distribute, 3 to the power 4, and 2 to the power 5. Let me move this to the beginning. So it will become as 3 to the power 4 times 2 to the power 4 times 2 to the power 5. Now, can we multiply here? Yes, we can. So the answer is 3 to the power 4 times 2 to the power. If we add 4 plus 5, the answer is what? 9. 8 over 10 to the power 2. We know that 8 actually is what? In this case, we can't, like, nothing common, we can convert 8 in terms of 10 or 10 in terms of 8. But we know that 8 is 2 to the power 3, because 2 times 2 is 4 times 2 is 8, divided by. Now what about the 5? Can we do it? Yes, we can. 2 times 5 to the power 2. So this will become as 2 to the power 3 over, now distribute the 2 here, 2 to the power 2 times 5 to the power 2. Let me do it this way. In this case, let me take this. Can we do the division here? Yes, we can. We only need to subtract the exponents. So it's 2 to the power 3 minus or negative 2 over 5 to the power 2. We know that 2 to the power 3 minus 1, which is 1, over 5 to the power 2. So again, what I did this division, and I kept this as it is, because nothing between the numerator and the denominator in terms of the 5. What about negative 5 to the power 2 times 2 times 30? We know that 30 can be written as what? 5 times 6. But again, the 6 can be written as 2 times 3. So it's minus or negative 5 to the power 2 times 2 times 5. I will not write 6, I will not times 2 times 3. Now what's common? The negative will remain as negative. 5 to the power 2 and 5. In case of the multiplication, we have to add. Similar basis, we have to add the powers. So 5 to the power, this power is 1, so it's 2 plus 1. So I took this with this. And then again, I need to multiply 2 times 2. I can't write it as 4, and I can't write it as 2 to the power 1 plus 1. And finally, for the 3, we have nothing. Similar to the 3. So it's negative 5 to the power 2 plus 1, 3. Times 2 to the power 1 plus 1, which is 2. And 3 will remain as 3. What about here? We know that 27, so we have 27 and we have 9. We know that 27 can be written in terms of 3, and 9 can be written in terms of 3 as well. 27 is 3 to the power 3, raised to the power 2. So I just replaced 27 with 3 to the power 3, times 5, over negative, because 2 is even, so forget the negative here. If it is odd, we should get it out. So we know that 9 is 3 to the power 2, and this should be raised to the power 2. Power to a power, we have to multiply them. So it's 3 to the power 3 times 2 times 5 over 3 to the power 2 times 2, which is 3 to the power 6 times 5 over 3 to the power 4. In case of the division, what we should do, similar basis, 3 and 3, we should subtract the powers. So it's 3 to the power 6 minus 4 times 5. So the answer here is 3 to the power 6 minus 4 is 2 times 5. Please like and share the video. Please also subscribe in this channel. Thanks for watching.